thanks, Paul. So I'm going to talk a little bit more about the ICR infrastructure. I should caveat this. The last 2 times I've given this presentation, I've literally been walking from seat to lectern. My phone has gone off to let me know we've had a major network failure. So we've thought about this long and carefully, and we've concluded the most sensible course of action is to switch my phone off. So hopefully we can carry on uninterrupted today. So we have an HPC infrastructure. We only have about 1,800 cores, which is much smaller than most university sites and many of the institutes here. What I would say is that those cores are fairly well provisioned. Our entry point is 12 gigs per core. More commonly, we deploy 16 gigs per core, and we've got 2 petabytes of scratch storage attached to our main cluster. It's designed for an embarrassing or nearly embarrassingly parallel workload. So we don't do a lot of MPI. We're not doing a lot of molecular simulation. We're basically dominated by genomics at the current point in time, although we do expect that to change. Our average utilization is 70%, which again might seem rather low compared to a typical university system, but we're in a slightly different game really. Our HPC is dominated by trying to process data from instruments. And whereas in a university environment where you have lots of simulation, more cores means quicker runtime or greater resolution, we're just trying to stay ahead of the instruments with a little bit of overhead to cope for uneven workload or if runs fail, etc. So that's the reason it is like it is. I mentioned we've been dominated by NGS, but with new imaging systems appearing and EM, and we have a new proteomics facility that's just going live now, we do expect our workload to change in nature, and that's going to apply to storage as well. Our next upgrade, we actually just completed our last upgrade 3 hours ago, and my phone stayed quiet, so we'll take it as a good sign. But our next upgrade is going to include support for GPUs as well as CPUs. We do have support for GPUs on the ground at the moment, but in ICR it's very much a cottage industry. We've got small-scale development, codes and problems that don't really need to scale to very large volumes, and there's some questions about the quality of some of the software that people are running at the moment. So as that all matures, we'd expect to centralise the support for GPUs a little bit more, but we're not quite there at the moment. Now, having all this kit is great, but we need somewhere to host it, and we've run out of space and power in London. There's just about nothing left. So we took a decision a couple of years ago that we'd start moving our infrastructure to an off-site data centre outside of London in the Slough area. In the UK, we have a commercial framework where universities can make use of this facility at comparatively competitive prices. And we've had to connect our sites to that data centre with private 10 gig networks. We do use the Janet infrastructure that you find in the UK at academic sites, but we're not directly on the backbone. So we've had to provision our own links to Slough, which I'll talk more about in a moment. So ICR has 3 sites. Paul and I are based in Chelsea, which is the black star in the middle of London. That's where all the tourists are. The red star is our Sutton site down in South London. We do have some RDS storage there. And the other red star is where the remainder of our RDS storage is. That's out in Slough. If you've got really sharp eyes, I never noticed this before, but there's a little blue dot just to the left of Reading. That's actually my house, because I wrote this talk at home and I didn't spot it when I cut and pasted. So there you go. It's a very nice area. So here's our networking infrastructure. So we have 2 zones of storage in Slough, which I'll come back to in a moment. We have another zone of storage in Sutton. The dotted line between Sutton and Slough represents that we've just had our 10 gig network delivered, but we're not routing traffic down it yet. We expect that to start in the next few days. But the upshot is that you can imagine a city like London, there's lots and lots of building work going on. People do dig through pavements and they dig tunnels all the time. So if we lose any part of that quadrilateral, the traffic will just reroute the other way. We could see some deprecated service, but we shouldn't see a cessation of service. Okay, so we can keep going. You'll notice our storage is therefore geographically distributed by some distance. That costs a lot of money. So the link from Sutton to Slough, for example, over 5 years is about 150, 160,000 pounds to operate. Why go to the trouble and the effort? Well, this very unfortunate picture is taken from the CR UK Centre in Manchester back in April, where they had a major fire. Nobody deserves this to happen to them, but it was a timely reminder that bad things do happen. And the very next day after this incident, rather than having people asking me why this extra network was costing so much money, I had users ringing me saying, this thing you're building, it is at multiple sites, isn't it? And we were able to say, yes, most definitely it is. So that's the reason we've gone down that route. So onto the storage system itself. Paul mentioned some of the things the users wanted. I was also equally interested in what does my team want. Okay, we've got to run the thing. We've had a little bit of a difficult time with storage over the years, so I wanted to know what the guys wanted out of this solution. Naturally, they wanted something that was simple to manage. That's a no-brainer. Well supported by the vendor, again, obvious. Very resilient, so that it could take small knocks easily. This is an interesting one. A system that can tell the support team what it's doing. Now, this is a little grumble of mine, and it doesn't just apply to DDN. I think it's across the whole sector. I think this comes back to reinventing the wheel again. There are too many storage solutions out there that are very complex, and you buy them, and then you don't really know what they're doing under the hood. You have to write your own monitoring tools, your own alerting tools, and then you typically spend the first 12 months of operation writing email filters, yeah, to work out which of the 10,000 emails you've got overnight actually matters, yeah. And I'm sure that many of us have been through this process multiple times, and you have to ask if this is a sensible thing, yeah. I'd argue very much not. Whether or not it's a good business decision, I can't really comment on, but it's kind of painful for us as customers. We wanted to be able to manage the capacity provision and recharge for the reasons Paul mentioned. All the usual fault tolerance stuff, both hardware and the users. You know, this is a multi-user environment. We do get new users who haven't been in this kind of environment before, and mistakes happen, and we'll just leave it at that. Yeah. Really, we want a quiet life from a support point of view. We want empty help desk queues. So this is what the architecture looks like at the moment. We have sources of data at the top, which Paul mentioned briefly. Also, we have legacy data from our old platform. We've still got several hundred terabytes of data stuck on tape that we are moving onto our new platform. We will be doing that for months. We have staging areas between instruments and the main storage platform. We entirely agree that moving data is painful and you don't want to do it too often. But if you do have to move it, then we want to move it in a controlled manner. So instruments right to staging areas. It's automatically copied off onto the main storage platform overnight. That way, if there is a problem on the RDS or we need to take it down for maintenance or whatever, I no longer have to ring 25 different labs and say, when's a good day for you? Yeah, that was becoming logistically impossible. I'll move on, actually. So, Tier 1 is sorry, there's that word again, GPFS. I do apologise. It's a GPFS stretch cluster. So we have one block of storage in Sutton, and we have another in Slough, and it doesn't matter which one you write to. It's generally sensible to do something that's geographically local, but it will be synchronously mirrored across to the other site. Tier 2 is made out of an object store, which I'll talk more about in a moment, and then we have a layer of bridge servers in the middle to connect the whole thing up. We are using what's called a global object-to-shore configuration, so we use 3 zones of WAS storage. And and we've got an overall capacity of 2 PB on the top layer and 4 PB on the bottom layer. So if I write a file, it gets copied. When it's old, and I'll come on to policy in a moment, it gets moved down to tier 2. It's an object which is distributed in 3 different places, and then it gets stubbed at the top layer. So what that's presented as to the end user is that everything is still there. Yeah, so it looks like nothing's happened at all. When you retrieve the data, you may get a slightly different retrieval time, or in some cases, very different retrieval time. But everything is still there and it's all in one namespace. So from the user's perspective, it looks nice and simple. It's just one big bucket. As of today, we allow users to access data via both SMB and NFS. Usual caveats apply about mixing protocols. I suspect that we may change our position in the next few days. We have a configuration meeting coming up, and we are questioning the wisdom of trying to run both protocols at the same time. We may lose NFS, but I'll come back to that in a bit. Users simply have to point at RDS, ICR, ACUK and mount it as a network drive. It uses a round robin to load balance between NAS gateways. And we can also have sub-round robins if you want to just access the ones that are physically closest to you. ICR uses a piece of middleware called Centrify quite extensively to map Active Directory credentials into Unix UID, GID pairs. Not the only way of doing it, of course, but also we have this thing called zones. And what that allows us to do is to take a user who may have perfectly valid credentials, but until they've come to and spoken to us, they can't log on to our HPC and they can't store anything on our storage platform. We have to actually add them into the right Centrify zone. And that's just, it allows us to have a conversation with those users to make sure that what they want to do with our facilities is reasonably sensible. I think we've very rarely said no to anything, but there are policies that we do need to make people aware of as well. We have about 140 research teams at the moment. We allocate all of them a tier 1 file set on the GPFS layer, and we pre-populate directory structure for them. That follows the organisational structure of ICR. So everybody has got a division, unit, team, person directory. We don't really care that much about what they do under the team layer, but it means that whatever storage system, be it the RDS, if they log onto HPC, they always see a common directory layout and they know exactly where to put their stuff. We know exactly where to apply quotas and so on. We take snapshots every day. They're retained for 90 days by default. Again, that's something we may be about to change. The snapshot also includes object IDs of stub files, which have gone off to tier 2, which is important for recovery. And every file set has a quota on it, and that's the basis of our recharge. Data can be moved from tier 1 to tier 2 based on bridge rules. At the moment, we say if you haven't accessed your data for 30 days, it's a candidate for migration. We don't migrate anything smaller than 10 megabytes because that's not a very efficient use of object storage. And instead, we just rely on the simple replication between the two sites. It's more efficient. We do support no migrate options for people that really don't want their data to migrate down. They want it live all the time. That might be because it's reference data. It might be because of very spiky workloads on the data. And we can actually support a per team policy for migrations if they really need it. No one's actually come to us and asked for one yet, but then equally we're not really advertising it, but the facility is there should we need it. One important point at the bottom there, we cannot quota usage of the object store. Okay, so an object store does not support native quoting. So instead what we do is we supplied a tool by DDN, which allows us to measure the usage. So we get a daily report of tier 2 usage. If people are going beyond what they've purchased, they get a phone call from me, which starts out as a very pleasant phone call. And then phone calls get slightly less pleasant as we go on, but everything generally works out in the end. Now, Paul said we're on a journey. I'm going to tell you about some very recent bumps in the road. And I'm really happy to report that 2 of those bumps have now been paved over. Everything's good, we're happy. There's one that we're still scratching our heads about a little bit, but I'm sure we'll get there in the end. So, firstly, we've got this issue of poor bandwidth when reading the contents of data that was stored on tier 2. So you see the arrow on the left. If you use something like wget to pull something directly out of the object store, you will easily, every day, you'll get a bandwidth of 200 megabytes per second, or better, 300-400 sometimes. When we tried to access the same object going through the top layer, through the NAS servers, through NFS or SMB, through the bridge down to tier 2, and to read the data, the bandwidth we were getting was 10 megabytes per second. And that's pretty grim. So, not surprisingly, we reported that. There were 2 issues in play, actually. Firstly, we had a WAS node quietly die, which it wasn't very verbose about telling us. That accounted for a factor of 2, so still not fantastic, but that was some of the issue. But also, in our specific WAS enclosures, the 9660s and the hard drives that are inside them, there was an issue with latency. So if you do a sort of single-threaded retrieval of data, you just want one object out of the store, you get very high latency and very little concurrency in the retrieval process. Okay. Now, DDN looked at that, they understood the issue, they worked on it, gave us some software patches, and at the moment we are back up around 100 megabytes per second on retrieval process through that method. Now, that's not hugely fast, but then we never wanted performance out of that tier. You know, it's designed to grow to many, many tens of petabytes if we need it to. It's therefore, if not cold, then very cool data. So for us, that's something we can work with. We're happy enough about that. What did we learn out of that? Well, and again, this has come up before, you really need to put a realistic workload onto ideally a trial system when you're doing procurement, but then building a prototype system that's made out of 2 different layers with a bridge in the middle and geographically spread across the southeast of England is perhaps a bit of a stretch for most vendors. So more realistically, I think were we doing this again, we would ask companies like DDN to set this up in their lab environment, because that's what really revealed the issues of what were going on, and we would do that now as part of our procurement process. So that was not so great, but we got through it. DDN did really well to fix that one. This is the scary one. This is the one that kept several of us awake at night. So because of this bandwidth issue, one of our sysadmins kindly offered to rehydrate, as in physically copy a file from tier 2 to tier 1 to help a user. And as soon as the user tried to use it, it said, "This file is corrupt." And we all went, "Oh, that's interesting. I do love a problem." And worse still, we could never reproduce it. So we took the same BAM from a different source, we put it on tier 1, pushed it down to tier 2, rehydrated it back to tier 1. Perfect, not a problem. And we did this for several days, and we tried it many different ways and all sorts of combinations. And I had to go back to the user and say, "Look, I don't know whether this is good news or bad news, but we can't make it do it again." Which is not a great situation to be in as a service provider. But anyway, again, huge credit to the DDN engineering team. They actually, after trying for a couple of weeks probably, managed to replicate exactly what was going on. And it comes back to our old friend, the failed WAS node. So if you have n WAS nodes and the data gets pushed down, all well and good. If a WAS node subsequently failed and you tried to rehydrate, the object was not correctly reconstructed. But then when you try to repeat the test and you're on n-1 WAS nodes, it gets pushed down. When you retrieve it, it comes back perfectly because it's never going to the down WAS node. So that's why we could never replicate this problem. Much as we never wanted to see this issue, I think the fact that the DDN lab was able to reproduce the exact circumstances and fix this problem with another software patch, I think is credit to them. I don't know what the lesson learned from this is really, because it just went straight past our user acceptance tests. It's such a specific scenario. But what I would say is if people are having weird and wonderful issues like this, get the DDN labs involved ASAP, because they can go really deep into a problem like this. And you know, they're there to help. Please use them. And this is the one that's still an issue, a little bit in progress. We've noticed as the services become more popular and as we start to move more and more data around, occasionally we get what appears to be flapping services. And again, this appears to be a problem, at least our sysadmins think so, that might originate on bridge, and you get a DMAPI failure. The NFS service then starts blocking. Other services assume that it's down when it isn't down, it's just blocked. They start to try and migrate services around, and the whole thing gets into a tangled knot, and you get a million emails and nobody really knows what's going on, and it takes a lot of unpicking. And then it moves on to the next NAS server, okay, and you start the process all over again. This is ongoing, and again, we need to get the DDN team more involved in this now, because it's a very recent problem. We suspect it's load related. We suspect, and there may be more than one view in the room on this, that perhaps the whole media scaler, NFS, CTDB, the whole stack is maybe a little overcomplicated, a bit overcomplex, and a little bit oversensitive to small errors or delays. You know, lack of response from one service affecting another service. And perhaps we just need to have a sort of step back and try and simplify some of the software services that are within this platform. It's not something that is having high impact on the users. They are largely unaware of this issue because we can just move things around and put other NAS servers in play. But it is something that's giving the support team something more of a headache. I'm sure it's a problem we'll get to the bottom of. It's not a problem that is keeping me awake at night, I have to say. It's just one of those things. With a new service going into production, you find these things out.
Are you using IBM NAS services, or how are you providing the Samba and NFS? Is
It's the media scaler.
Okay. We had similar problems with IBM before.
Okay. It needs further investigation, and I say it happens under load. There appears to be a correlation, but we've seen correlations before that turned out to be false positives. So I think we have to get more deeply into this problem. As I say, not one that's keeping me awake overnight, but I would like to get to the bottom of it fairly soon. And that's us really. So Paul and I would both be happy to take any questions.
Okay, are there any questions?
Jürgen Heiner Billy from Paul Scherrer Institute. I have two questions. I mean, first, the easy one, the quick one. How is the WAS, the web object scaler, connected to GPFS? Is it an external storage pool?
Has the object storage connected to GPFS?
Is it configured as an external storage pool?
So the object store is connected to two pairs of bridge servers, and that's responsible for the migration up to the GPFS layer. Is that?
I say the software side, the configuration side. How does GPFS know about? How?
Is it a policy? So it's not a policy to move data back up. That's on user demand. But we have policies for each team about how data is migrated down. So the default being If you haven't accessed the file for 30 days and it's bigger than 10 megabytes, move it down. So it's policy driven in that sense.
But so it's probably an external storage pool, but you don't know for sure.
So it's
an external storage pool.
Yeah, kind of.
Kind of. Okay. Then
James? Okay.
Thanks, James.
I assume you're using DMAPI for that, right?
Yeah.
Okay.
Yeah.
So there's no TSM involved. It's just straight
There's
up.
no TSM, no.
Okay.
Second question?
Other questions?
question. I mean, you do synchronous mirroring, and you have 10 gigabit between the sites. That means the maximum peak throughput is 20 gigabit if you go full duplex, yeah. But you also have the VOS traffic, which may cut a bit, yeah.
Yep.
I mean, 20 gigabit peak isn't that great if you talk about petabytes, yeah. Did you think? I mean, how do you think? How will you solve this? Did you think about asynchronous mirroring?
We did. We looked at AFM for asynchronous moving. Our friends in DDN preferred the synchronous approach. What we did when we procured the networks between the sites, we made sure we had a very clear upgrade path to go to 20, 40, 100. So the limiting factor there will be money. But there won't be a technical limitation on getting to higher bandwidths. The latency was something that they were more worried about, actually. But as it transpires, we have very good latency between all three sites.
Andy?
Could you just show the picture of the whole architecture again, where you got the...
This one?
No, keep going, back.
Keep going. Say when.
The one where you showed you different boxes. So my question, this one I guess, maybe do. So your equipment writes to the staging areas, and then you said an overnight policy writes it to the research data store. So
Well, it's not so much a policy, it's more of a cron job.
Whatever, yeah. Does the HPC platform see the staging area, or how soon in this pipeline can you start to process stuff on the HPC platform, or if you're writing stuff out from an experiment?
So there's an arrow that isn't shown there. So most staging areas write to the RDS, but we don't mandate that. So when we deploy a staging area, we have a conversation with every team that needs one, and we ask them what they want, and in some cases the staging area will just write straight to scratch instead. And it doesn't have to be overnight. It can be as soon as the run ends off an Illumina piece of kit, for example, because there's a file there that tells you the run has ended. So we have a script that looks for that and then stages immediately.
So that's straight to the scratch on the HPC
Yep.
platform? Yeah, okay. I was just curious.
We used to write directly to scratch, and the reasons we didn't was because it was too much of an unstable multi-user environment, or the wild, wild west, as we sometimes call it. And for some instruments, they're really quite sensitive to that. Not so much the sequencers, but things like our mass spec machines are very, very sensitive to their storage target not responding. And that can be quite, you can lose the run, and it can be destructive for samples as well. So.
Stefan Schenk, you mentioned that you organize the file system depending on the layout of the organization in the Active Directory, which is kind of a cool idea. Thanks for sharing that. Given the size of your organization and the size of my organization, I'm wondering how you keep track with your organizational changes, because it gives you a hard time if you need to do changes in the directory layout on a constant move.
Did someone pay you to ask that question?
My boss, they give me salary, you know.
There have been issues where the organisational records in Active Directory have departed from reality, and that does give us headaches, to be
But it's a matter of weeks, I would say, to really have these discrepancies. Just telling from my own experience, in the old systems, over 5 years we had like 3 or 4 code changes which are reflected in the AD. And do you have any cool ideas on how to cope with that?
Well, one of the reasons we use quotas on file sets rather than Unix groups is because some people are in the wrong Unix groups, but we can put them all in the same file set, and work at that level, which is perhaps not our proudest moment, but it does actually work.
Yeah. Maybe this is too technical, but I am really curious. Your approach in the Tier 1, I think, is, if I understood well, you have two geographically separated data centers, and you have a unique file system.
Mm-hmm.
So how it is set up, you rely on AFM disaster recovery mode, or you have kind of a VPN and two different data pool sets with two-way replication?
No, there's no AFM in the solution at all. It is one stretched cluster. And if we do lose connectivity between the two GPFS sites, let's say, for example, a British telecom engineer opened up a cabinet somewhere in Chelsea and pulled the wrong wire out, for the sake of argument, then what we have to do is... These things just come to me, George.
This already happened, I guess.
Then we do have to resynchronize the two GPFS zones, if you like, and that takes us, well, it depends how long the outage was for, but typically it's half a day or something like that to resync.
What do you use for that, for keeping both them synchronized? You rely on something provided by IBM, or you...
It's purely GPFS internals, as I understand it, yeah.
Okay, so you have the same internal networks between both sites?
Yeah, there's a private layer 2 connection between the two sites
that
doesn't carry general academic traffic, it's just to carry scientific computing traffic.
You allow simultaneously writing in both sites, and you don't get any race condition problems and so on?
Not so far, no.
So, okay, interesting. Thanks.
And I think it's always a challenge when you're doing this Tier 1, Tier 2 stuff. I stay away from it now. I mean, try to avoid it at least, or at least give us a demarcation between the two, so the user knows when they're transitioning to or. And actually, we're just going to move away from that and like do this kind of allow them to do it. So I really commend you for doing that. So yeah, and then the other thing is, I remember. Let's say you had, yeah. But I thought I thought there was a problem with snapshot consistency with DMAPI or something like that. When you're with objects, you can become disassociated.
Not that I'm aware of.
I've researched this a bit. I'm a little out of touch with that issue, but I remember something there. Maybe that's been fixed in the meantime since I looked at it a few years ago.
Can't comment.
Any other questions?
So what's your strategy in case you lose, let's say, one piece of the Tier 1 storage? Let's say a very disastrous scenario. Let's say you totally lose one of the systems in Tier 1. It's replicated, so you lost no data, but you replace the system and you get a new one and it's empty. So what do you do?
Okay, so we can run off one of the two Tier 1 pools. So we can run in a sort of business continuity mode. Assuming a new box magically appeared the next day and we deployed it elsewhere on our estate where we could host it and we had sufficient networking. It's a good question. How long would it take to resynchronize everything? Would that be the right way to go? We're working on our business continuity plans quite a bit at the moment. I should imagine we will attempt some sort of resync because we like this architecture and we want to get back to it. But yeah, it would be practically challenging to do that, but at least we could do it. And a single site has got no options, so...
It's very difficult to test.
On that note, I mean, I'm paranoid, so it's like, do you do a metadata dump or something like that? Could you restore? I mean, this is the problem a little bit. You don't have a backup of that.
Yeah, not at all.
That's the catch, right?
Yeah.
Well, the metadata on GPFS is backed up to the object store.
Yeah. What?
The metadata on GPFS is backed up to the object store. So if the Tier 1 and Tier 2 both went south, then yes, we'd have a problem.
You could restore it.
We can restore the GPFS metadata from a backup copy on the object store.
You can rebuild the metadata layer from...
Well, I haven't tested it personally.
It's
dynamite on paper.
Right. Do you pre-migrate the data or no?
Sorry?
You force a pre-migration to the object store, or no? I'm sorry. This is TSM. Never mind. Sorry.
Well, the question is, do you pre-migrate the data? Do you copy the data to tier 2 as soon as they are modified on tier 1, or only after some time?
Now, the standard route for going from tier 1 to tier 2 is that you haven't accessed it for 30 days on tier 1. So we don't immediately migrate and then stub. We wait for 30 days because a lot of the data that goes onto RDS, then people may have a look at it and decide actually that data's not so great, and then just get rid of it anyway.
Then you cannot do a disaster recovery from the WAS.
I need to think about that, but I think we can. But
there's some interesting scenarios there. I love the architecture. I'm like, wow. I mean that was my fantasy architecture, but I didn't have the cojones to do that. I really didn't.
I'm not sure.
So,
Brought that back home.
no,
we better carry on. But I really thank you so much. That was a great conclusion of presentation. So I really inspirational.